Good evening, students. Today we will solve a LPP with the help of simplex method. This is the LPP in which the objective function maximum z equal to 40 x plus 20 x2 x1 plus 20 x2, and the inequalities are 4x1 plus 2x2 less than equal to 20, x1 plus 3x2 less than equal to 40. We have step first is first convert this LPP in standard form, standard LPP, then add the slack variable because the sign is less than equal to, and then represent above data in matrix form. Okay, so we have two equation. First adding the slack variable, then equation first is 4x1 plus 2x2 plus x3 equal to 20, and equation second is x1 plus 3x2 plus x4 equal to 40, and we add the two extra variable, extra slack variable, one is x3 and other is x4. Then the equation is maximum z equal to 40x1 plus 20x2 plus 0x3 plus 0x4. Okay, and the matrix form of this question is ax equal to b. The matrix A is the coefficient of the left hand side of the equation 1 and 2. The matrix is 4 2 1 0 1 3 0 1, and the x is the variable x1 x2 x3 x4, and in right hand side we have b. B is a resultant of the equation, that is 20 and 40, 20 and 14. Okay, in step second, the simplex table first is, this is the simplex table first, in which the basic variables are the x3 and x4. Okay, the basic variables are x3 and x4. CB is the coefficient of x3 and x4, that is 0 and 0. XB in column XB we have 20 and 40, 20 and 14, and CJ, in CJ we have the coefficient of max Z, that is 40 is that is 40 is C1, 20 is C2, 0 is C3, and 0 is C4. And the first column x1, this is the first column x1 in which 4 and 1, first element is 4 and second element is 1. Second column x2, that is 2 3. Third column x3 is 1 0. Fourth column x4 is 0 1. Okay, and the after completion of this simplex table, our target to find the key element of the outgoing and incoming vector. Okay, first is the incoming vector. For finding the incoming vector, we have the data is zj. For finding the incoming vector, we have delta j, and delta j is equal to zj minus cj, which is equal to, we know that about zj and cj in our previous lecture. We know about zj and cj. We have delta j equal to zj minus cj, and we know that zj is cb xj minus cj. Okay, where x1 x2 x3 and x4 in our question are the column vector, and cj we have the coefficient of max z is c1 c2 c3 and c4. Okay, that is, if you want to find delta 1, delta 1 is z1 minus c1. z1 minus c1 is z1 equal to cb xb. Cb is this column, multiply with x1, and the multiplication is element wise multiplication, that is 0 multiply with 4, 0 multiply with 1, 0 multiply with 4 plus 0 multiply with 1 equal to 0, minus c1. C1 is 40, then resultant is minus 40. Similarly, delta 2 minus 20, delta 3 0, and delta 4 0. Okay, we know about the incoming vector, we know about the process of incoming vector. The most negative delta j, the corresponding column of most negative delta j incoming vector. Okay, the the incoming vector is the column with respect to most negative delta j, and outgoing vector is the minimum of xb upon xk, where all xk greater than 0, that is the incoming all the elements which are greater than 0 in incoming vector uh, are xk. Okay, then in this question we have the most negative is -40, that is the x1 is incoming vector, and the outgoing vector is the according the minimum ratio of incoming vector with xb, according the minimum ratio of incoming vector with xb, that is the minimum ratio of xb upon x1 equal to 5 and 14. 5 is minimum, so the x3, this is the outgoing column, and x1 is incoming vector. Okay, and the key element at the point of intersection of incoming column and outgoing vector, the key element is 4. This is the key element 4. Okay, uh, in in the second simplex table, we are using the key element for construct second simplex table, because all the delta j are less than equal to 0. So the solution of this question is not optimal according the rules in our previous lecture. We know about the rules of the simplex optimality of the LPP in simplex method. That is, if all delta j are greater than equal to 0, the solution under the test will be optimal. Okay, if corresponding to any negative delta j, all element of the column xj are negative or 0, then the solution under the test will be unbounded. If at least one delta j is negative, the solution is not optimal, and then proceeding to improve the solution in the next step. Okay, in third rule number third, we have all the delta j are less than equal to 0. So according rule number third, if at least one delta j is negative, the solution is not optimal. Okay, the solution is not optimal, and the proceeds to improve the solution in the next step. Okay, we have all the delta j are -40, -20, 0 and 0, and all the delta j are less than equal to 0. That is, we need simplex table second for finding the optimal solution. Okay, and we have the outgoing vector and incoming vector in simplex table first. According the outgoing and incoming vector and key element, we can construct the simplex table second. Okay, this is the simplex table second, in which we have x1 is incoming vector and x3 is outgoing vector. At the place of x1, okay, this is the simplex table second. According the simplex table first, x3 is outgoing vector, and at the place of x3 we can put x1. Okay, this is the x1 which is incoming vector. The coefficient of x1 in objective function is 40. So at the place of cb, at the place of c1, we can put 40. After dividing all the elements by 4, which is key element in simplex table first, we have the row number first is 5, 20 divided by 4 is 5, 4 divided by 4 is 1, 2 divided by 4 is 1 upon 2, 1 divided by 4 is 1 upon 4, and 0. For finding the row number second, cb is 0, For finding the row number second, we can use the rule is R2 equal to R2 previous, R2 previous, R2 in equation in table number first, which is 14, 1, 3, 0 and 1. This is the R2 minus alpha R1 latest, and alpha is the element. This is the alpha element. This is 1 is the alpha multiply with R1. R1 is the latest row, that is 5, 1, 1 upon 2, 1 upon 4 and 0. When we multiply alpha with R1, then we have the resultant row is 5, 1, 1 upon 2, 1 upon 4 and 1 upon 0. After subtracting R2 minus R1, we have the latest R2 is 9, 0, 5 upon 2 minus 1 upon 4 and 1, which is 9, 0, 5 upon 2 minus 1 upon 4 and 1. Okay. Again, for finding delta j, we can use the procedure delta j equal to zj minus cj, and the points are delta 1 is z1 minus c1, z1 is cb x1 minus c1, cb is 40, 0 and 1, 0 minus 40, which is equal to 0. Again delta 2 equal to z2 minus c2, 40, 0 and x2 is 1 upon 2, 5 upon 2, x2. This is the x2. This is the x2. We have, this is the x2. For cb is 40 and 0, and x2 is 1 upon 2, 5 upon 2 minus 20. The resultant is 0. Again similarly delta 3 is 0, delta 4 is 0, and we have all the delta j are greater than equal to 0. This implies the answer is optimal. Now the optimal point is x1 is 40 and x2 is 0. x1 is 40 and x2 is 0. And the optimal solution of this question is z equal to max z equal to 40 x1 plus 20 x2. The optimal point is x1 5 and x2 the optimal point is x1 5 and x2 0. According this, x1 equal to 5 and x2 we have only one point, x1 equal to 5 and the x2 is 0 and x3 is 0, x4 is 9, and we need x1 and x2. Then x1 is 5 and x2 is 0, then max z equal to 40 into 5 plus 20 into 0, the resultant is 20. Okay, this answer is optimal because all the delta j are greater than equal to 0. Okay friends, this is the solution of linear programming problem using simplex method. Okay, in our next question and next lecture we will learn about a problem in which the solution is unbounded. Thank you.